Okay, in this video, part 2, we're going to actually graph the function we worked on in part 1. And we have an x-intercept and a y-intercept at 0 and 0, and we determine that f goes through the x-axis. So here we have our x-intercept, and we also have a local minimum at -1 and -1 over e, which is close to -1/3. So we have a local minimum here. F is increasing from -1 to positive infinity, so it's going to get bigger and bigger in this direction, right? Now, is it concave up or concave down? Well, we determined that it was concave down from negative infinity to -2 and concave up from -2 to positive infinity. So starting at this minimum, it's going to go like this in a concave up fashion. It's going to look very much like e to the x is what it's going to do. It's going to start here at this local minimum and go way up like that. Okay. Now before that we have an interesting inflection point here at -2, an interesting little feature, and this is roughly -2/9. Okay, if we consider that e is 3, and so right here we're going to have a change in concavity, and from concave down to concave up. Okay, right here at -2. If f is decreasing from negative infinity to -1, then that's from left to right. It must be increasing from right to left. So it's getting bigger and bigger and bigger, but it can't cross the x-axis. So this would imply that we have a horizontal asymptote at y equals 0. It has to be getting closer and closer to the x-axis, but it can't cross it. Because it's decreasing this way and increasing in this direction. So we have that feature of a horizontal asymptote. Now we can take the limit of x e to the x as x goes to negative infinity and show this, but we need L'Hopital's rule to do that. You might not have that. I'm going to do that at the end anyway. And here's what our graph looks like. And that's not very good, but it's getting closer and closer to the line y equals 0 out here. It comes down like this, and it changes from concave down to concave up, and then goes to infinity this way. Now, in order to show that as x gets big in the negative direction, that we get closer and closer to 0, we can take the limit of the function, the original function, x e to the x, as x heads to negative infinity. And we notice that this is infinity times 0. If you just take some time and look at this, you might stop the movie and go through this limit. And so I'm going to set it up as x over e to the negative x. Okay. And now I've got infinity over infinity, negative infinity over infinity. And so I can use L'Hopital's rule, and I take the derivative here, and it's pretty clear that as this thing gets big in a negative direction, this becomes positive, and this goes to positive infinity times -1, and so it gets closer and closer to 0 while staying negative. So that pretty much shows that you do have this horizontal asymptote on the back side of this curve.